Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as Assistant Professor at Sharad Institute of Technology, College of Engineering, Edra, Ichalkarji, Kolhapur District, Maharashtra. We are looking to computer or we are going through computer graphics software. So here some contents we are going through. First one is introduction, that are general requirements, a ground rule or comment of graphical software or graphic software, functions of a graphics package or you can say software, method of defining 2D curves, line, arc, circle, etc., and the algorithm of line. So, introduction over here. The graphic software is the collection of program written to make it convenient for a user to operate the computer graphics system. It also includes a program to generate images on a CRT screen. CRT means cathode ray tube screen to manipulate the image and accomplish various types of interaction between the user and the system. In addition to the graphic software, there may be additional program for implementing certain specialized functions related to CAD/CAM. These includes design analysis programs such as finite element analysis and you can say kinematic solutions, etc. And the manufacturing planning programs, for example, and also manufacturing program also, that is automated process planning and numerical control part programming, etc. A CAD CAM system contains different categories of softwares, as we can see here: operating a system, uh, graphic software, application software, and programming support software. Here in operating software, the major function of this operating software is to allocate the resources of a digital computer to the various programs needing them. A typical functions such as file manipulations, we can say that you might have seen that save as, rename, copy, delete, etc. Right? That manipulation, managing directories and subdirectories, programming, and accounts setups are supported by the operating system. In computing time, even in computing time, memory space, input, output devices are controlled and allocated by the operating system. The operating system also detects programming errors and provides an orderly recovery or restart when one is encountered. The operating system also classifies the files that are generated by CAD CAM software into text file and graphics files. The, the general purpose operating systems you might have heard about that are Unix, Linux, Windows based operating systems such as Windows XP, Windows 2000, etc. So here next is a graphic software. The graphic software provides users with the various functions to perform geometric modeling and construction, editing and manipulation of existing geometry, drafting and documentation. The standard graphics software provides geometric building blocks such as point, line, curve, circle, rectangular, ellipse, box, cylindrical, prisma, sphere, torus, and you can say surface of revolutions and all. The shaded images, wireframe models, dimensions and tolerances can also be generated by using this graphic software. The of application software, creation of the creation of the geometric model of an object is not the end goal of users. The ultimate goal is to be use geometric model for design analysis and manufacturing. Several application software packages are commercially available for the purpose of mass property calculations, assembly analysis, tolerance analysis, finite element analysis, as I said, uh, mechanisms analysis, sheet metal design analysis of plastic injection molding, and also animation techniques. Right. Next, a programming support a software. Here, software development takes place through programming languages. Programming languages are broadly classified into interpret and compilers. Some of the general purpose programming languages are Fortran, Pascal, C, and Basic, DAL, and grip have also been used for graphics or design applications. Now we'll see a requirement of graphics software, or we can say the ground rule of the graphic software. That first is a simplicity. The graphic software should be easy to use. Consistency. The package should operate in a consistent and predictable way to user. And completeness. There should be no convenient omissions in the set of graphic functions. Robustness is the graphic system should be tolerant of minor instances of misuse by operator, and this performance is within the limitations imposed by the system hardware. The performance should be exploited as such as possible by software. The graphic program should be efficient and speed of response should be fast and consistent. And last is the economy. The graphics program should be so large or expensive as to make their use prohibited, right? So these are some requirement of graphics software. You can also say ground rule. So now we'll see the functions of graphic package, or you can say software. Here, in the graphic software must perform a variety of functions to fulfill CAD CAM requirements. For that, some common functions are as a generation of graphics primitive elements. Uh, the graphic primitives are two-dimensional and three-dimensional geometrical element. Uh, the two-dimensional graphic primitives are line segments, arc, circle, parabola, hyperbola, and ellipse. The three-dimensional elements are box, cylinder, prism, sphere, cone, and torus. The graphics software should be generate the basic primitives and should also have a library of regularly used geometric features such as involute gear tooth, various types of threads, and etc. Now, transformation. This is a transformation. These are used to modify the image on the display screen or to reposition the graphics items in the database. The transformations are scaling, translation, and rotation. This transformation helps the user or helps us the constructing a geometrical model fast. The weaving or display control and display control and windowing. While model construction involves the creation of the model database, weaving affects the way the model is displayed on the screen. Views are defined by the various angles from which the model can be observed. The views are isometric view, orthometric view, perspective view, front view, top view, side view, left view, rear view, and bottom view, etc. If the object is too complex, if the object is very too complex to show its entirety, windowing is often used. An imaginary box is created around the portion of the object of user's interest. Windowing results in the displaying the portion of the object encompassed by imaginary box. Though next point was is segmenting. The segment is this function provides the user with the capability to selectively edit the text, such as deleting or modifying portions of geometric model. And user input function is the user input function should be accomplished to maximize the benefits of interactive future of interactive computer graphics. The user input functions permits the user to enter commands or data into the system. Here our line methods, you can see here a method of defining 2D curve, and that is line, arc, circle, conics, etc. So these are the commands, that line, circle, this 2D commands, and here is the 3D commands, a box kind of, right? And this is the, we can say, 3D modeling or 2D modeling coordinates like this x and y and z, kind of, right? Next, the line drawing algorithm. When if you see here, the method of defining line, the method of defining this line using two previously defined forms. uh, Method of defining lines includes what is using one point and specifying the angle of the line with the horizontal, or using a point and making the line either normal or tangential to the curve, using a point and making the line either parallel or perpendicular to another point, making the line tangential to two curves, and so on. You can make such kind of methods used for lining, draw a line, right? So now we'll see the line draw algorithm. The primary design criteria for the line drawing displays as a line should be appear straight, line should be a start and end accurately, line should have constant brightness along the length, displayed lines should be independent of line length and orientation, line should be drawn rapidly. The line drawing algorithm is of three kinds or three algorithms for drawing a line. The one is DDA line drawing algorithm. DDA is a digital differential analysis, and next one, prism line drawing algorithm and midpoint line drawing algorithm. So we'll see this digital differential analyzer line drawing algorithm because it's a very easiest and many of them are following that algorithm. So here the digital differential analyzer algorithm is the simplest line drawing algorithm given the starting and ending coordinates of a line, and this DDA algorithm attempts to generate the points between the starting and ending coordinates. Procedure, we'll see the procedure now. Given starting coordinates, that x0 y0, if you say here x0 and y0, x0 and y0, and ending coordinates x and y, and somewhere here it's going like this, or somewhere here somewhere xn and yn, means this is xn and this is yn. The points generated using DDA algorithm involves the following steps. See, step 1, calculate delta x, delta y, and m is the differential equation. Hence, now we see here that step 1, that calculate delta x and delta y and m, that is governing differential equation of a straight line, that is nothing but delta y divided by delta x from the given point. The parameters are calculated as delta x, that is delta x is uh, xn minus x0, xn minus x0, so we'll get delta x. And here similarly, delta y is delta y minus delta, sorry, yn minus y0, will get delta y. So differential equation, that is m equal to delta y divided by delta x. Now step 2, find the number of steps or points in between the starting and ending coordinates, right? Next is the step 3, is suppose the current point is xp or yp, or you can say x1 y1, and the next point is xp1 plus 1, here yp plus 1, means if I say here x1, I can say x2, this is y1 and this is y2 plus 1. So find the next point by the following the three cases according to this, as shown in right side. If the case 1, if m is greater than, or sorry, lesser than 1, then we'll follow this step. The next, if m equal to 1, will follow this case, and if m is greater than 1, will follow, consider the case 3. We'll go step 4 is keep repeating a step 3 until the end point is reached, or the number of generated new points, right? So that is includes starting and ending points equals to the steps count. We'll clear this with the help of example. We'll take one example practice problem based on the DDA algorithm. Calculate the points between the straight line or straight point, that is 1 and 7, that is x and y, or you can say x0 is 1, y0 is 7, and the ending point is xn 11 and yn is 17. Right? So solution is given a starting coordinates x0 y0, that I said x0 y0, that is 1 and 7. Ending coordinates xn and yn is 11 and 17. Step 1 was calculate of delta x and delta y and m from the given input. So delta x is nothing but xn minus x0, xn minus x0, that is 11 minus 1, that is 10. Xy, delta y is nothing, is equal to yn minus y0, yn minus y0, that is 17 minus 7, that is 10, and m is 1. So you can see here m comes 1. So case 2 is satisfies. Now step 2, calculate the number of steps that are both are 10 10, isn't it? So you can see here the delta x also 10 and delta y is also 10. So or you can see here 1 2 3 4 5 6 7 8 9 10, x and y as 10. So number of steps that delta x equal to delta y is 10, and as m in step 3 as m equal to 1, so case 2 is satisfied. So case 2 is here satisfies. So now step 3 is execute until step 4 is satisfied. Step 4 is what? Step 4, you have to be keep repeating step 3 until the end point reached or the number of generated new points equal to the steps count. So if we considering or plotting these points, we, we are plotting here these points until the end point reach. So this is what here 11 and 17. Are you getting this, please? X is 11 last point and y is at 17. This is a last point. This point is 10 and 16. This is 10 and this is 16. Similarly 9 15, this is 9 and this is 15. Similarly 8 4, this is 8 and this is 14. 7 13, x is 7, y is 13, x is 7 here, here, and y is 13 here, this point. So plotting a point and take a line, this is a straight line algorithm. So some advantages of DDA and disadvantages also there. So we'll see the advantage of DDA algorithm. It is a simple algorithm. The advantage is it's a very a simple algorithm, and it's easy to implement, and it avoids using a multiplication operation which is costly in terms of the time complexity. The disadvantage of DD algorithm is there is an extra overhead of using round off functions. Using round off functions increase time complexity of the algorithm. Resulted lines are not smooth because of round off functions. The points generated by these algorithms are not accurate. So guys, this is what we have gone through the software, graphic softwares, computer graphics softwares. So we'll see in the next session soon. Thank you so much.